What's up, guys? Welcome back to Vanover Customs. In today's video, we continue on with this beautiful Lion lathe rebuild, and we're going to be focusing in on motors specifically. This beast has two main motors, one that powers the actual spindle and the other one that powers the rapid carriage. So we're going to be getting into both of those motors and taking a look, making sure they're good, and if there's anything wrong, inspecting and replacing bearings and any other parts we need to do to make sure these guys are ready to do work. Let's get in close and show you what we're working with. We're over here at the back of the lathe where the main spindle motor mounts, and I believe this is a 15 kilowatt motor. Before we went ahead and started this project, I did fire the motor up and it sounds excellent. So I really don't anticipate having any issues with this motor. But that raises the question, why would we go ahead and get into this? And the main reason is right now I have some downtime and this machine is about 40 years old, 41 I think actually. So I'd much rather come in here while I have the time, take it apart, clean it, and know that it's going to be good and put it back together, as opposed to assuming it's good and then later when I'm busier and I have tons of work, having a motor failure then and have to deal with it then. So the first step is going to be to take the back cover off and undo the pulley, and then hopefully it looks like we'll be able to swing this motor out on this mount and take the motor off of this motor plate. Well, you would have thought I seen around this corner, but I didn't. Next step is to get this pulley removed, and I have a bunch of 3-jaw pullers, but frankly, they're just not large enough. And being that this motor is in pretty good shape, most likely, and this pulley is pretty expensive to make, I really don't want to attempt it and break the pulley mainly. So I thought I'd give this a shot with our bearing splitters and my spreader bar, but I didn't realize until this moment that my spreader bar doesn't fit these threaded rods. We got this bad boy off the lathe and I have it up here on the bench, and I thought I'd pull out some of the additional motors and take a moment and just talk about motors in general. So there are two types of motors, AC and DC. Now DC is direct current. Usually they have brushes, sometimes they can be brushless, but I really want to focus on AC motors and talking about how to rebuild and what to look out for AC motors specifically. So the first thing you want to watch out for when it comes to the restoration or refurbishment of these AC motors is removal. Obviously on these smaller ones it's not as big of a deal, but when it comes to the big guys, you need to be prepared to lift these, and they can be pretty heavy. I think the next thing that's can be kind of a gotcha is removing the pulleys. Now you kind of seen me struggle with removing the pulley on this guy because I didn't have a big enough 3-jaw puller, and I think it's something that you need to be aware of if you're planning on restoring a motor, because you got to be able to pull the pulley, and a large motor like that, sometimes they can be really stuck on there. So luckily nowadays they do make some cheap Chinese 3-jaw pullers. Otherwise, the OTC snap-on ones and the German ones are pretty pricey, so just keep that in mind. Now, there are really two types of AC motors that I'm going to be talking about, and that is sealed versus open. So an open motor is more common on older equipment like the KNT, the Shaper, and a couple of the other old equipment in my shop. And basically the frame of the motor is exposed. And they did that back in the day. I'm not sure why, probably for ventilation. And the motor itself is mostly the same as a sealed. However, the main issue with that is over time, dirt, dust, grime gets in the motor and can kind of ruin the motor. So in an ideal world, you'd have a sealed motor, which is pretty common for anything in the last 40, maybe even 50 years. And all these motors right here are sealed. So when it comes to sealed motors are actually quite durable, because theoretically they keep out all of the grit, grime, and dust, and that is really what can knock out a motor. And in general, a sealed AC motor is very durable. Because all the elements are kept out, there really isn't a lot of moving parts in a motor to go bad. Namely, the bearings are the most obvious. But other than that, because there are no brushes and nothing actually contacting anything, there's just not a lot to go wrong. And that's why AC motors are so widely used in industry, because they're pretty rock solid. Now obviously if your bearing goes bad and wears the shaft, stuff like that can cause an issue. But for the most part, if the engine isn't smoked like these are, an AC motor can easily be rebuilt and brought back to life fairly simply without much to do. So let's just talk about the steps in actually refurbishing an AC motor. So the first one's pretty obvious, but it is important, and that's just inspecting and cleaning. So when it comes to looking at the cases, you just want to make sure there's no cracks or breaks, anything like that, or anything that you see with the shaft, galling or anything like that. That's something you want to be aware of. With a lot of AC motors, you want to be able to spin the shaft and have it move freely. And there's going to be a little bit of drag, but if you have any grinding or you hear any noise, that's going to be indicative of a problem. The other reason why the inspection and specifically the cleaning is important is because when you're talking about a sealed motor, because it's not an open frame motor, it is cooled usually by a fan. So on all these you see there's like a cage on the back, and basically a fan lives in that cage, and the fan spins and forces air around this cage and onto the fins. So on a lot of these machine shop motors, these fans will have chips and grime packed in the fins, and so they're not able to cool efficiently. And so there is a really high benefit to come and clean all of this, so that way when the air passes over them, it's doing a lot of effective cooling. So that can shorten your life if your motor has a bunch of like chips and stuff packed in. The motor can run hot, and so cleaning the motors really does help with that. The other thing which I've touched on is bearing replacement. So after you've inspected and cleaned everything, you want to start to pull the motor apart and actually check and replace the bearings. And that's what the next step here is after we clean these guys. And that's really not that difficult. Obviously, there's going to be some special tools to get the bearing pulled off the shaft and out of the end bells, but replacing the bearing is relatively straightforward once you get the bearing out. And then shaft repair, on most motors that's not going to be an issue, but if you have people kind of monkeying around with the pulleys or keyways, or the bearing was shot, the shaft itself can be damaged, and you don't want to put the motor back together with a shaft that's damaged specifically where the bearing is, because then the shaft is kind of bounce around on the bearing and not do its job. So that's something you want to watch out for. The other thing you want to watch out for when you're kind of taking these apart is the wiring. Now the wiring is stationary and it doesn't really move around. It's fixed in place, but it is good to go ahead and do a resistance check on all the windings to make sure it's good. But just kind of a layman's terms way to approach it is, if you took the motor out and it was running, it sounds good, and electrically there were no issues, it's probably going to be fine. The biggest issue is on older motors like this. A lot of the wiring is old and brittle, so specifically when you're undoing stuff in the front of the case, you can kind of snap or break a wire, and you want to be careful of that. But aside from that, as long as it was working before and there were no issues, it's probably going to be fine from a wiring standpoint. But you do want to be careful when you're cleaning the wiring on the inside. You don't want to go and hit that with a brake cleaner, because the wire is actually coated with like a lacquer type material so that they can wrap it and they can touch but not short out. So you want to be careful not to break down that insulation. But other than that, the wiring is pretty straightforward. And then the last thing is, once we get the bearings replaced, inspect, clean everything on the inside and outside, we're going to reassemble and paint. And that's really, really simple and straightforward. We just put everything back together and give it a fresh coat of paint, and you're pretty much done. And that is kind of the main point that I want to make here, is that with AC motors that aren't destroyed, the shafts being destroyed, they're really a great thing to rebuild yourself compared to taking it to a motor shop. A motor shop is going to do everything that we just talked about, and specifically, they're going to be the ones who are doing rewinding of motors. That's not something you're going to be doing at home, but for the most part, motors are cheap, and it's almost always better to replace the entire motor, especially on a smaller motor, than get it rewound. And if you have motors like this, which are mostly fine, but they just need a little bit of love, they're perfect candidate for rebuilding those motors yourself by mostly cleaning, inspecting, and swapping out some bearings. So that's what we're going to be doing on these guys. And just real briefly, let's talk about the 4 different motors we have up here and what our game plan is, and then we'll jump right in. So this is the main 23.5 horsepower motor we pulled out. Again, it checks good, it spins good. There's a little bit of grinding in the shaft. I can't tell if it's maybe the fan hitting the cage or just maybe a little bit of old bearings. We'll swap the bearings, clean it, should be good to go. That's nothing too crazy there. This motor is for the actual power carriage feed, and I think it's like a 1, maybe it's a 2 horsepower, same thing. Checks out fine, it spins good, it actually spins no noise, it's probably fine, but that should be fine. And then the other motor over here is the coolant motor. And when this motor was on the machine, it was never working when the last owner got it. So it was unplugged, it was seized up, and in the last 20 years, this machine hadn't had coolant. Now I could go in there and try to rebuild this motor, but with a coolant motor, there's a little bit more complexity because you have a motor and then you have a pump as one unit. So there's 2 different units there, and luckily I was able to pick up one of these coolant motors for about 50 bucks. I actually have 2 of them, and it's kind of an interesting story. This lathe is Bulgarian, so it's made in Europe. And I bought a bunch of parts from an old bison factory going out of business, and they make a lot of things in Europe. And one of the guys selling a bunch of parts had a couple of these coolant motors, and they're European made. It looks like they're made in Slovakia, and he sold them real cheap. And this motor is actually a bigger, I think it's a 2 horsepower. Yeah, a 2 horsepower motor. So it's actually bigger than this 0.5 horsepower coolant motor, and it has a larger inlet. It has a 3/4 inlet and outlet, whereas this only has like a 1/2 inch. So it has greater flow, it's cheap, and I already have it, and it's brand new, it's never been used, and I have 2 of them. So instead of coming over here and trying to restore this and spend a little bit more time, we're just gonna swap it out with an upgrade, and I also have a spare in case we ever have an issue in the future. And the coolant motors are more likely to go bad, not necessarily the motor, but more so the actual pump part, just because they're submerged in a nasty environment. So having a backup for that is gonna be real nice. So with all that out of the way, we're gonna jump in and start getting the motors cleaned. We'll start on the big one and kind of go from there. I don't know if you guys can hear that. They're a little bit grindy. They're not too bad, but guess what? We'll go ahead and replace them. We've come this far. Might as well replace them now, and hopefully the motor will run a little bit smoother. We got the motor apart, and let's talk about what we found. Overall, the motor's in really great shape. The bearings were a little bit grindy. I actually ordered some new bearings for $75 shipped for both of them, so that's a pretty good deal. So aside from the bearings, everything else looks good. There's only one minor issue, and that'll be really easy to address. If you look on the, I believe this is the stator or possibly the rotor, we have a lot of grease buildup around this area. And somehow, either from the bearings, because there was some grease coming out there, or somewhere else inside the motor, some grease got out and basically stuck to the rotor. And on the inside of the stator, it has a bunch of grease there too. Not a major deal, we're just gonna clean it off. but the clearance is pretty tight, and so in some spots this is sticking up pretty good. So that's going to add some extra resistance and possibly heat. So glad that we got this apart so we can change the bearings and get both the rotor and stator cleaned up. Should just make for a longer lasting, better running motor. Other than that, like we talked about, we'll just get everything cleaned up. I'll get it reassembled. Everything's going to be pretty much a reverse of what we did, very straightforward. So we're going to move on to the next one and start tearing that one down. Also, one more note, I looked up the equivalent bow door replacement for this motor, and it is about $7,300. Now that's MSRP. I'm sure you could probably get it for $5 or $6, but the point is doing this is well worth it. We're so far going to be in the cost of the bearings, which is 75 bucks, and a couple cans of spray paint and some cleaner, and that's pretty much 100 bucks out the door to refurbish this motor. Now obviously all motors aren't going to be able to be restored that cheap, especially if there's damage on the shaft, but in this case it makes a lot of sense to spend $100 and a Saturday rebuilding this guy. Completely worth it. We got all the components cleaned up and we're ready to get this guy back together. Now this is really easy to assemble, so we're not going to spend forever showing you how to do that, but just a couple quick notes. First off, I'm not going to be stripping this down and fully bondoing it and doing a bang up paint job on it. It's a motor. I will do a really nice paint job on the lathe, but you're not going to see this, and there really is no purpose. There really isn't even a purpose to paint it. But we have it apart, so I'm gonna assemble it, and then once it's assembled, I'll throw a quick coat of paint on it. Other than that, when you're assembling it, we just wanna be as clean as possible. I went ahead and just cleaned all this stuff down with the appropriate cleaner off camera. I did go ahead and just mildly polish up these journals with some emery paper just to get rid of any burrs. And then same thing with the bore on the keyway. So we'll go ahead and start putting this together and go from there. Got some brand new bearings. These bearings were cheap. I'm talking $20 or less for each one. So in this case, rebuilding this motor is real cheap. All right, that concludes the rebuild of these two motors. I'm gonna be honest with you, we made a mistake when I was rebuilding this bigger boy over here. I went ahead and pressed on a bearing and I forgot the back plate. So I had to pull the bearing off, not on the inner race, but on the outer race, which you're not supposed to do. And these bearings are pretty beefy, but in doing that, when I spun the bearing, it just didn't feel right. So I didn't want to chance it, so I went out and actually purchased some new bearings. And when I showed the bearing guy the old new bearings, he confirmed that I tweaked them and messed them up. So it's a good thing we did that. We got it all reassembled. Everything is very smooth, no binding, no noise on both motors. We throw a coat of paint on these guys just because, not necessary at all. You're not going to see these guys, but if anything, just for me to visually say they're done and to know that they're not super dirty, and very happy with the way they turned out. Again, the coolant motor is just going to be brand new, so that's that. Ironically, and I don't know if you guys are seeing this video before or after, while I was working on these two motors, the motor in my American went out, and so within 1 week I was rebuilding 3 motors. So I think that's pretty ironic, and I do have a video on that, so I'm not sure if that's going to be after this or before it, but you'll get to see rebuilding another motor. So lots of motor content. I hope you guys enjoyed this video. If you guys have any questions, let me know down in the comments below, and we will see you in the next Lion Lathe video.